Hey, charming young people. Today we will be doing derivation for differential equation of SHM, and based on that we will find formula for, first we will do differential equation of SHM, and based on that we will find formula for acceleration of body performing SHM, velocity of body performing SHM, and also displacement of body performing SHM. And then we will see what are the important cases. So are you ready to go with me? See, if I take a block of mass M connected with a spring like this, and if I try to pull it outwards, I know that there is a reaction force, there is a restoring force. Sorry, not reaction force, restoring force inwards. The more I pull it here, more will be this force. So the restoring force is directly proportional to x, to the displacement, but it is also directly proportional to the negative of x, because if the displacement is towards the right, the restoring force is towards the left. Even if you try to compress this thing, even if I try to compress this thing, if the displacement is towards the left, the restoring force will be towards the right. If you remove this, if you remove your hand with which you're pushing this, this force will push it outwards. It will push here, right? So in both the cases, this is only the formula. So we will introduce a constant of proportionality. F is equal to minus kx. Now we know that force is mass times acceleration. So mass times acceleration is minus kx. So acceleration is minus k over mx. Now this k over m will be written as, or root k over m will be written as omega. This is another derivation that we'll do some other day. So right now acceleration is just minus omega square x. We will remember this formula because we already got acceleration. We haven't got the differential equation yet. So we know that acceleration is basically derivative of velocity with respect to time, and velocity is derivative of displacement with respect to time. So acceleration is double derivative of displacement with respect to time. So therefore acceleration is d square x over dt square. So if I put this here, I get d2 square x, sorry, d square x over dt square is equal to minus omega square x, or taking this on the LHS, d square x over dt square plus omega square x is equal to 0. This is differential equation of a body performing SHM. Okay, for body performing SHM, this is very important. This can be asked as a 1-marker question even in your exam. That's just state the differential equation. Now based on this, we will try to calculate velocity and displacement. We already have acceleration. We know acceleration is minus omega square x. We will calculate acceleration at the two important positions, the mean position and the extreme position. So in SHM, in simple harmonic motion, you always have these two important positions. Consider a pendulum. See here, this is known as the mean position because it is the mean between the maximum displacement towards right and maximum displacement towards left. Here we always take displacement as 0. Here we take displacement as plus a, which is the positive of the amplitude. Here we take displacement as minus a. Okay. So at mean position, we know x is equal to 0. So acceleration will be minus omega square 0. So acceleration will be minus omega square into 0. So it will be just 0, which is the minimum value. Now in extreme positions, you always have two positions, positive extremity and negative extremity. At positive extremity, x is equal to a. So acceleration will be minus omega square a. Okay. And at negative extremity, x is equal to negative a. So acceleration will be minus omega square into minus a. So acceleration will be plus a omega square or plus omega square a. Correct? Now let us try to find the formula for velocity. For velocity, we know that acceleration is minus omega square x minus omega square x. We know that acceleration is dv by dt, derivative of velocity with respect to time. But the problem here is that here I have x and here I have velocity. But to integrate, I need dx. Dx so hey, we don't have dx. So we will do a little manipulation. This dv by dt can be written as dx by dt. Sorry, dx by dv into dv by dt. Okay, what I'm doing is I am manipulating this and writing this as dx by dv into dv by dt. Okay, there is a mistake here. Wait, I will be writing this as dx by dt into dv by dx. I made some mistake. This is dx by dt into dv by dx. See, anyways, this dx gets cancelled, and what we get is dv by dt only. So it's a valid substitution. Okay, so I will put it here. So this becomes dx by dt into dv by dx is equal to minus omega square x. Now this is basically velocity. So v times dv by dx is equal to minus omega square x. So v times dv is equal to minus omega square x dx. Let us integrate both the sides. So we get v square by 2 is equal to minus omega square x square by 2 and plus the constant of integration. Now we will find this constant of integration. To find the constant of integration, we know that at extreme positions, always at extreme positions, the body momentarily stops. Even if you consider this pendulum, when it comes here at the positive extremity or at the negative extremity, momentarily its velocity becomes zero. So when x is plus or minus a, v is zero. So let us substitute. Let us substitute these two things in this equation. 0 is equal to minus omega square a square by 2 plus c. So therefore c will be omega square a square by 2. Now let us put the c also here. So omega v square by 2 is equal to minus omega square x square by 2 plus omega square a square by 2. Let us cancel all the 2's. So v square, and let us write the positive term first, omega square a square minus omega square x square. Let us take omega square common. So what remains is a square minus x square in the bracket. Then you take root, so plus minus omega under root a square minus x square. This is formula for velocity, but again we will calculate this at mean and at extreme positions. Plus minus omega under root a square minus x square. So at mean position, x is 0. So velocity will be omega into plus minus omega into a square minus 0. So this will be just plus minus a omega. Now, if this is plus or minus, this depends on where the body is going. If the body is going towards the right and it is at the mean position, it is plus a omega. If body is going towards the left and it is at the mean position, it is minus a omega. Let us also talk about at extreme positions. So at extreme positions, x will be plus or minus a. In both the cases, x square will be plus a square only, right? Because even negative numbers square is positive only. So v will be omega plus minus omega under root a square minus a square. So this is equal to omega into plus minus omega into 0. So velocity is 0, which is the minimum value. This was the maximum value and this is the minimum value. Now let us talk about displacement. So we found that dv by dt, let us consider only the magnitude, omega under root a square minus x square. So, sorry, not dv by dt, this was velocity. So it is dx by dt, right? Dx by dt is this. So dx upon under root a square minus x square is equal to omega dt. Again, integrating both the sides. This is sine inverse of x upon a is equal to omega t plus a constant of integration phi. So x over a is equal to sine of omega t plus phi. So therefore x is equal to a sine of omega t plus phi. This is the final formula for displacement. But in this also we will take some cases. We will take three cases. Okay, so we have x is equal to a sine of omega t plus phi. Let us say that body starts from mean position. Body starts from mean position. Now, starts, this word implies starts, the word starts. This implies that the time is zero because motion is just started. It is just started. It is not even started. It is starting. So we are trying to calculate at that time. So we know x is equal to a sine of omega t plus phi. We know that it is at mean position x is 0 and time is also 0. So 0 is equal to a sine 0 plus phi. This a goes in the denominator. So 0 upon a is equal to sine phi. So that means sine phi is equal to 0. Phi is equal to sine inverse of 0. So phi is also 0. So if you put this here, you just get x is equal to a sine omega t. This is the final formula for body which is starting SHM from mean position. Now for extreme positions, we have two cases. Body starts from extreme. We have positive extremity. Body starts from positive extremity. And negative extremity we will see after this. So if the body starts from positive extremity, we know that x is equal to plus a, and obviously t is 0. As I told you, starts means time is 0. So x is equal to a sine of omega t plus phi. A is equal to a sine of 0 plus phi. A upon a we know is 1 sine phi. So therefore, phi is equal to sine inverse of 1, which is pi by 2. So if I substitute this here, I get x is equal to a sine of omega t plus pi by 2. So this is sine 90 plus theta. So in the unit circle thingy, pi by 2 plus theta is the second quadrant. Second quadrant mein sine is positive. So we get x is equal to a cos omega t. And since the transition is of pi by 2, sine becomes cos. Now, if body starts from negative extremity, if body starts, again, the word starts means time is 0, from negative extremity. Negative extremity means x is equal to negative a. So x is equal to a sine of omega t plus phi, minus a is equal to a sine of 0 plus phi, minus a over a is equal to sine of phi. So sine inverse of ये हो जाएगा -1 is equal to phi. So therefore phi is equal to 3 pi by 2. Substituting that, we will get x is equal to a sine of omega t plus 3 pi by 2. And 3 pi by 2 plus theta is fourth quadrant, because 3 pi by 2 is here and plus theta is here. So this is x is equal to, and fourth quadrant, sine is negative in fourth quadrant. So minus a cos omega t. So to sum up, d square x over dt square plus omega square x is equal to 0 is the differential equation of a body performing linear SHM. Okay, of a body performing linear SHM. Differential equation of body performing linear SHM Formula for acceleration is minus omega square x in linear SHM, and at mean position it is 0, and at extreme positions it is maximum plus minus a omega. Velocity is plus minus omega under root a square minus x square. At mean position, velocity is maximum, and it is plus or minus a omega depending upon on which side it is going, and at extreme positions it is 0. And we just saw about displacement. If body starts from mean position, displacement is a sine omega t. If body starts from extreme position, let us say positive extremity, if the body starts, it is a cos omega t. And if the body starts from negative extremity, starts from negative extremity, x is equal to minus a cos omega t. Okay, my dear students and lovely people, I will see you in the next video.